you're going to need this piece of cardstock, and you're going to turn it horizontally. Take the one that says Lunar Cycle Flipbook that says shade the moons to indicate which area is light and which is dark. That's the one we're going to start with. We're just going to glue this one down completely. Well, what we could do, and we're not going to, is you could make it into a booklet where underneath this you take notes, but we're not going to do that. You just glue everything down. You can cut off the dots on this one. You're going to need them on the other one. I would leave the title on this one as well, and then you can cut it off on the other one. Oh, all right. Well, that's fine. Whatever. All right. So you're going to cut it out, and it will look like this. And then you're just going to glue that whole thing down. Yeah, you are. Hey. You're talking on my video. Okay, so then you get it glued on. It looks like this. Very easy peasy. Then you're going to cut this one, making sure that this time you absolutely keep that tab. You didn't necessarily need to have it last time, but now you need it. And you do not need to keep the title on this one, because if you kept it on the other one, or if you just want to glue it on later separately, that's fine too. So the picture on both of these is exactly the same, but we are going to be doing, we're going to be using them for two different things. So when you cut that out, then it looks pretty much the same as the other one. You're just going to put glue along the top of the tab above where the dashed line is, where you're going to fold it. Just a minute, huh? So when you glue that on, match the tabs up, and then you're going to fold it on the dashed line, which makes it into a flip book. Yeah, MacBook Pro, there you go. A MacBook Pro. Look, Mom, no computer. My kids have done this before. They have they were banned from playing the Wii U one day, so they made they made a fake Wii U game controller, and they pretended that they were playing like a Mario game or something. They were like, ah! See, so entertaining, so entertaining. So when you hole punch this, my recommendation would be to hole punch it at the top so that you can put it in your booklet or in your notebook sideways. Where is my hole puncher? Over here. Please excuse my departure from the video. I'm getting the hole puncher. So there's the hole puncher. I'm going to hole punch it at the top with a flip. And that way then, when we put it into our folder, we will put it in there, the folder that I bought for you. You're going to put it in like this so that when you, it should be facing, look, when you put it in here, it should face this other page that we colored the other day. That'll be helpful when we are actually coloring this page, okay? No, that's not the plan. It's not a bad idea though, is it? Okay, so. We're going to work with the first, or with the one that we glued down first. I'm going to take a black and yellow crayon. Just use a light and dark. It doesn't really matter what colors you use. I don't care. But we are going to start, bless you. we are going to start with the bottom page on this. So if you go to the bottom page, that'd be your keyboard, right, on your MacBook Pro? That would be your display. So we're going to shade the moons to indicate which area is light and which area is dark, okay? And I'm going to do, oh, it would help if I plugged the sun in, wouldn't it? Yeah, whatever color you use to represent light and dark, just make sure you know which one is light and which one is dark. You could actually put a key on your paper to indicate that, okay? So here's the sun, my sun of science, all right? Here's my globe of science. And here's my moon. It even has the man on the moon. Here, I'll show all the people on here. Look, there's the man on the moon. Yay! It would be helpful if I had a gray moon, but yeah. Anyway. So this is the moon. Now, the moon goes around the Earth, right? It is a satellite of the Earth, and it goes around the Earth like so. Now, I will turn the lights down. This might help if we have the lights turned down. It might not help people on the video because the video is going to be a little fuzzy. Sorry, people. But that's just the way we go. So when I put the moon in between the Earth and the sun, this being the right side, this being the left side, which side is lit? The right. So on this picture, take the moon that is in between the Earth and the sun, and actually you can color the sun if you want later. You can color the Earth later. You probably didn't get the right colors right now. But so on this picture here, let's see, all right, we can see. So we're going to take the moon that's between the Earth and the sun, and we are going to color it to indicate that the entire right side is lit and the entire left side is dark. So, right, well, look at it. Is it half and half? I mean, you almost have to be sitting straight on, but Kayla, is it half and half? Yeah. So the whole right side of the moon is lit, and in the video, wow, you can see this really well in the video. It doesn't even look like it's a little red squishy ball. It just looks like a bright blob. Okay. So you're going to take and you are going to color the entire right side of the moon on the diagram. The one that's in the Earth and the sun. You're going to color the half and half. Yes. So it's going to look like that. Okay. It should look like this. Right? Okay. Now, let me get my little moon of science. So the moon is going to orbit the sun, and it's going to move along. Let's say right here. This is the next one up. Okay. How much is in light and how much is in dark? No. Stop. Look at this.
I can't. You're on.
Here, I'll come over here. Does that help? How much of it is light and how much of it is dark? Half and half. Oh my God, it's the same. The whole right side of the moon is going to be lit, and the whole left side of the moon facing me toward the Earth, or well, the Earth is here, is not. It's dark, right? So again, so in that case, the one that I started with this guy, but then I moved it up front to do this guy. So this guy right here is going to be the whole half light and the whole left half dark. Half and half again. Okay, so it looks like this. Looks like this. Okay. All right. Now, So if we'll continue going this way now. So then we get over, and we're right here now. How much of our moon is lit and how much is dark? Half and half. Which side is the lit half? The right side is lit. The left side is dark. Oh my God, do you see a pattern here? Are you seeing a pattern here? No? Not yet? Okay, we'll keep going. So the whole right side is lit. We'll talk about that in a minute. Well, you'll see. All right, so we just did this one. The right side is lit, the left side is dark. Okay, now, if, as we continue to move around the moon, if, this is a big if the moon rotated in a plane around the Earth's middle, then yes, we'd have a problem as we start to go around here and behind. It would never be lit behind the moon or behind the Earth, right? It would always be dark back here. Well, isn't it fortunate for us that the moon orbits the Earth tilted, so it comes down low over here, and then it comes up high, and guess what? It's up higher. So what side is light and what side is dark? The right side is light, the left side is dark, and it's still half and half, right? Yeah, lucky for us, right? What's that? Yeah, you can pretty much color them all the same. You're right. So for all of these moons, you are going to be showing that the right half is always the half lit, and the dark half is always on the left. Now, because the Earth is also rotating on its axis and it's revolving around the sun, the orbit of the moon, which is tilted across the plane of our orbit by 5 degrees, things don't always work out perfectly where it's always up above or below, so we see it like that. Now, that's why we sometimes have eclipses, because there are times in the orbit of the moon where it does cross in the middle of the Earth. For example, that happened on August 21st, right? It crossed in the middle of Earth's orbit, and that doesn't happen. That happens maybe once every year and a half or so. So somewhere on the Earth, every year and a half or so, the moon will come across right in the middle. Now, the video, you can see this really well. There's a nice big shadow right here on the Earth. There it is. Okay. What you can't see very well in the video is, and I'll show this on the board, but is the umbra and the penumbra of the shadow. When you make a shadow with something, the center part of the shadow is always really dark, and the outer part is not quite so dark. You can almost sort of see through it, okay? But so because the orbit of our moon is sometimes up high and it's sometimes down low, it's always sort of moving around. So sometimes it does come across during the day and it creates a solar eclipse. And also sometimes at night, it does come behind the Earth and creates a lunar eclipse, okay? So a solar eclipse is an event that happens when the moon lines up with the Earth's orbit and is directly between the Earth and the sun. So a solar eclipse is when the moon blocks the sun's light. Because the moon is an object that is blocking light, and when things block light, they make shadows. Why doesn't it? Because the moon is little. The moon's actually really little, okay? And like, we're gonna watch a video maybe tomorrow or the next day. I'm not sure. But the video is about eclipses, and it will tell you that the eclipse usually produces a path of totality on the Earth that's less than 100 miles wide, which means the umbra, which is the darkest part of the shadow, which is a total eclipse. You have to be in that part of the shadow to see a total eclipse. And the path for that is usually no larger than 100 miles wide, which means like on August 21st, we were not in the path of totality here in Pittsburgh. We got to see a partial solar eclipse. But trust me, a partial eclipse is nothing compared to a total eclipse. I got to see a total eclipse in 1985. I was young. I was like in 5th or 6th grade. But it was amazing. When the moon is directly in front of the sun for like, I don't know, 30 seconds to a minute or so, you can take off the glasses, or you don't need your pinhole viewer. You can look right at it and you see the corona. No. Not when the moon is completely blocking the sun. However, it doesn't last very long, so it's not like you can stare at it for a long time. Only the sun does. Yeah. Four? Yes, but where?
Here.
Not here. Not in Pittsburgh. I think it's going to be close, but Erie. Yeah. You have to go north. Not too far though. Yeah, that's definitely something that you could travel for, and I would totally recommend it, even if it's a school day. Anyway. Oh, well, you'll be in college. No, not all of us. You're right. So you'll have to take a day off work, maybe. But anyway, listen. Let's see, 2024. How many years is that from now? That's less than 10. So yeah, I'll be taking a day off work, unless it's in the summertime. Anyway, so then it comes around, and it might end up at some point behind. Now, it's more common to see a lunar eclipse. They happen once about every 6 months. Why do we think it's more common to have a lunar eclipse than it is to have a solar eclipse? Well, look at the shadow. All right, see the shadow? Look at the shadow now. It's much bigger. Look, the moon could be up here, the moon could be down here. It's got a lot of area to cover that can still be in shadow, right? Okay. Over here, the shadow's tiny, right? And in fact, I mean, that's like a big shadow. Like if I really wanted to make it, I would bring it out like this, and then you've got this little shadow. Now, let's take a look at the Umbra and Penumbra. I hope this works. Okay. I hope this works, but I don't know. It might not work. All right, so the closer that I get to the board, you can see the darker the shadow is, right? Can you see that? I'm not sure, like, do I need to bring it up or down, or I don't know. But if I get closer to the light source, do you see how the inside of the shadow sort of starts to get smaller? But then you've got this outer part of the shadow that is lighter, yeah? Ryan, can you pick up my computer and sort of put it over here on this desk? Yes. Keep it facing toward, yeah, there. Just set it right there, and I'll turn it toward, there you go. Let's see, does that work? A little bit. So you can kind of see that in the video now too. So basically when the shadow is out here, the umbra is really large and the penumbra is real small. I'm not even sure if you guys can see the penumbra.
What is the penumbra?
The penumbra is here. As I take this away, the umbra is this dark center, and then the penumbra is this part that's like grayer, okay? The penumbra is not a complete shadow. It's like a lighter part of the shadow that you can see through. So when there's an eclipse, if the eclipse comes across this way, across the earth, the only people that see a total eclipse are the people that would be located in the umbra. Everybody that's in the penumbra will see a partial eclipse, because it's not going to block the whole sun, basically, okay? So as we pull that away, the umbra gets smaller, the penumbra gets bigger. I don't know what's so funny. I'm missing the joke here, apparently.
No.
Okay, all right, enough. All right, now, go ahead and flip to the other. So we finished this one. This one should look like that. Basically, every side of the moon is always lit. It's always the right side of the moon that's lit. Now, is that what we see from the Earth? No. So if we went into space and we looked, we would always in space see one side of the moon being lit and the other side of the moon would be dark. Because the moon does rotate, it rotates very slowly. It actually takes the same amount of time as it goes around the Earth. So it takes about 27 1/3 days, or about 28 days, which is about a month, right? Okay. So as it goes around here, it's actually rotating. It actually takes 27 1/3 days to rotate as well. So we always see the same side of the moon. So like, here's my man on the moon. The man on the moon is always facing us, but that means that it is turning, okay? Which also means, is there ever a dark side of the moon? A side of the moon that never gets sun? No. Okay? Because it's always turning, even though it's turning slowly. So like when you hear songs that are called like the dark side of the moon and stuff, that's not real. There's not really a side that never gets light. Now, it's true that one side may get light for a long time, right? See, look, my smiley guy, he's still in the sun, right? And now he's like half in the sun, but now he's not. Well, I got a smiley guy on the other side too. See, I'm cheating, but anyway. So we see different things from the Earth than we would if we were in space, okay? So when we are over here, this is our new moon phase, right? Okay, so on this side, on the flip part, okay, if you look at the one that's in between the Earth and the sun, so this one right here, what side do we see from the Earth? Here, look. Now, where did I just put my moon? There he is. Here you are. Hello, little guy. I'm sorry I lost you. We don't want to feel bad. Okay, honey. I don't even like dogs. I don't like cats either.
Oh my God,
I don't like animals.
oh my God, you're mean.
Yes, they're not my chickens though. My chicken died, and my kids were glad it wasn't one of theirs. I had one. I had one. I called it Marsala, and her nickname was Marcy. You ever heard of chicken Marsala?
Yeah.
My son and I have this. Yeah. He was the first one though that got on this track. He named his Nugget because his favorite food is chicken nuggets. And then he has one called Drumstick too. Because to me, they're food. We talked about it. My husband said that we could get one to replace my chicken, and I would get to name it. And I said, I'm going to name it Cacciatore and call it Cat. Chicken Cacciatore? Or how about Romano? Chicken Romano? Chicken Parmesan? Yeah, chicken Parmesan. Parm. We'll call her Parm. That's cheesy, I know. All right, anyway. We're off track. Anyway, it's so easily, I'm so easily distracted. Anyway, so what are we seeing here? So we're here on the Earth. We're not seeing a full moon. We see this side. It's dark on this side. It's light on this side. We're not over here. We're over here. So we see the side that is not lit up, right? So draw what we see. What are we seeing? We are seeing it in complete darkness, right?
Oh, I'm in a new moon.
Yes, this is the new moon, right? Now, will we see it? Well, we can't. Technically, we don't see it, but the side that's facing us is dark. Now, if it's right in the middle, then we would have an eclipse. But usually, it's sort of up here, or it could be down here, which the shadow would not be on the Earth side. Okay? Because remember, it's tilted by 5 degrees. So it's either going to be too high for us to have an eclipse, or it's going to be too low. Every once in a while, about every year and a half, it will pass in the middle and give us an eclipse somewhere on the Earth. Okay? So somewhere on the Earth, there would be an eclipse. It could be in Africa, because it could be daytime in Africa when it happens, and nighttime for us, which would mean, unless you're traveling to Africa, you're not going to see it. But a solar eclipse, where the moon blocks the sun, happens during the new moon phase. Okay? You might want to make a note of that somewhere on your sheet. It wouldn't be a bad idea to have that there, so that you can remember that a solar eclipse only happens during the new moon phase, because the moon has to be in between the sun and the earth. Okay, now, the next place that the moon goes is this way. It actually rotates this way. So what we see from the earth, now this is going to be hard for you, but if I look at it from here, all I see is this little sliver of Mr. Moon's cheek. Oh, look, honey, look, there, you're lit up right there. Oh, sweet baby. The rest of it we see is dark. This is our waxing crescent. So look at the one that you guys made the other day. Okay? Gee, I'm so sorry that I made you so bored. Okay? Yeah, get it. Now in the video, there's no way they can see this in the video because it's just not the right face. But you might be able to see this. Can you see that just the cheek of him is lit up? Can others of you see this? Yeah, all right. So it's a waxing crescent. So the right side, remember, wax on. So the right side of the moon, go up one. It actually travels this way. Yep. I did it backwards the last time because you guys complained you couldn't see it. Yep. You're going up, up. Okay? Up, 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 up. No. So that's our waxing crescent. So you're going to come to your diagram and you are going to color the very right side in a crescent shape, and the rest of it is going to be dark. So it's going to look like that. Like that. Okay. Now, as we continue, we're going to manage to get, oh wait, I got to keep my face shining there. So look, how much of my face is lit up right now? Half, yeah, half. This is our first quarter, okay? Which half? Right or left? Right, so waxing, right? Waxing. So first quarter is waxing. So we're going to do half, the right half. So the right half is lit up. The left half is dark. That's first quarter. Okay? Now, as we come around this way, and I'll keep my face pointing toward the earth, how much of my face is lit up now? A lot of it, but not all of it yet, right? So this is a waxing gibbous, right? Okay, so this is our waxing gibbous. So you're going to color a little more than half of the moon in light, and the other bit is going to be in shadow. So it's going to look like that. Okay. Now, when we get back here, how much of my face is lit up now? All of it, right. So which phase is this? Full moon, right. So you're going to take your diagram and you are going to color the entire moon yellow. Full moon. All right. So this is going to end our waxing phases. All right. So the next phases are going to be waning, right? So the next phase is this one, which is a waning gibbous, right? Okay. Because just this little bit of the moon over here is dark. So we're going to color the left side now yellow, and the right side is in darkness. Here, do you need to see that again? So it looks like that. Right here, okay? So if you're looking at the moon from the earth, this is the side that's dark. So I'm backwards. You would have to turn yourself around and face it that way. So this is going to be the left side, and this will be the right side now. Okay? Now, as we keep coming around, it's going to be hard for you to see this. But my face is facing here. Remember we said it's half and half. It's, well, I guess you can look at this side, right? But it's the opposite side of the moon that's going to be lit up. So it's not going to be the right side because that's what you're seeing from outer space. But what we see from the Earth is the left side. So it's waning, and this is going to be our third quarter. So now we're going to do half and half. But we are going to light up the left side, and we are going to keep the right side in darkness. So now your picture looks like that. Okay? Now, before we get back to their moon and before the bell rings on me, we're going to be coming around this way. And again, it's going to be hard for you guys to see because you're seeing the opposite. But what I see over here is I see the left side with a little sliver lit up, and the right side has a bigger portion that's in darkness. What's that going to be? A waning crescent. Right. So do you understand, or at least slightly better, why we see the phases of the moon? Is the Earth's shadow hitting the moon for the regular phases of the moon? No. What is it that is creating the light and the shadow on the moon? It is the sun and the side that is facing the sun, not the Earth, right? The Earth's shadow never falls on the moon unless we have a lunar eclipse, right? We only have a solar eclipse when the moon is between the sun and the Earth, and we only have a lunar eclipse when it's behind the Earth, okay? All right, you guys have any questions before the bell rings? Yes, ma'am. The moon revolves. Okay, so if we are looking down from the north over it's going counterclockwise, which is prograde. That's the same way that the Earth rotates, right? The Earth also rotates in that same direction. It's prograde. Okay, now most moons orbit their planets in prograde. There are one or two that go retrograde. I think there's one that goes around Neptune. I think it's Triton, that is going backwards. So, but most of them are going to rotate in prograde around their planet. Most planets rotate in prograde. Okay, there are a few though. Remember that go in retrograde for rotations. Huh? Uranus, Venus, and Pluto, but Pluto's not a planet. Alrighty then, that's the end of our video today.